spec. Right. And then what happens? And soil is dry. Right? We turn on pump. Right? So we're just going to go set this whole thing up here, right here. And then we're going to set up our LCD. We're going to set up our outputs. All our sensors, we're going to read them once, just to make sure they're all correct. Nothing's broken. I would say if sensor is bad, alarm or error. And then once we know all our sensors are good, we're going to go into our main loop. We're going to check our temp and humidity. We're going to check our moisture sensor. And then we got to answer these questions. That's our software build, basically, right there. Right?
Mm-hmm.
So this is where you need to kind of go with the software here. What you had here, if you could, can you share your screen? I'll send this to you guys right now.
I tried. Can you guys share my screen? Can you guys see my screen?
Yeah. Yes. You can.
I'm trying to make where is it? I'm trying to make the one for the LCD. And like down to the register.
Yeah.
So something like this is because this is only like making the LCD displays value.
Okay,
I haven't gone to the part that
yeah, you're
actually.
probably gonna have. There's usually an Arduino library for this.
Yeah,
So
but aren't we supposed to like
I want you to go down to the register level for this,
yeah.
if you can, because it just makes you think. Because there are going to be turn this off. There are going to be products you're going to be working on in the future where you're going to have to be going down to this level because you don't have a library. You're gonna have to write it yourself.
Mm-hmm.
So yeah, but for the most part, you're sending character data to this LCD.
Yeah.
And then I want you to kind of figure out what data you have to send data to the sensors. I think you do to set those up. Like the temperature and humidity, you have to probably tell them it's Fahrenheit or Celsius. And then how often to send you data, or do you have to trigger it to send data or whatever? So you might have to send a request for data, or sometimes you can tell the sensors to send you data at a timed interval.
Okay.
That makes sense? You're on the right track, gentlemen. You're doing a good job.
So out of those you just talked about, there was like communications between the microcontroller, the sensors, and the LCD, right?
Yep.
So that sounds like a lot of like sub functions and stuff.
Yep. Oh yeah. There are 15,000 lines of code in a electric drill from Milwaukee Tool.
Oh.
So I'm not asking you to make that many, but just to know, it's all be pretty bad, pretty big sometimes. So
for like for something I made here, do you think we have to go like this?
This is good. This is good right here.
Good. Okay. So we can like try to copy this format and like show the steps and the signal and where's the destination, like where does it go.
Yep.
So
this is perfect.
Okay. Good. So if anybody else have problem with their software task, because I want to move into PCB.
Okay. That was my next question, is how are the PCBs going?
Yeah, so anybody else has problems with the software task?
So this assignment, we just follow the professor you just did that
I emailed it.
.txt file. Okay, I got it.
Okay, so if nobody has a question with the software task, I'm gonna move on to the PCBs.
Great.
I have one question. Is that we discussed to like changed our temperature and humidity sensor to HT110
Okay.
and so like so it's like okay or
Can you show me the data sheet for that sensor?
data sheet okay.
What's the reason that we are switching the sensors?
Because like at the last semester we doing the Arduino one that we made, like, and Ding Yang says yes, he used is the AHT10, not the HTC 1080, because and so he's no
So you mean he used it before?
Yes.
Is there an Arduino library for this sensor?
Yeah.
Okay, that makes it easier. That makes it a lot easier.
Yeah, because I cannot find the other ones library, so I just use
Okay, that makes sense.
my own one.
That's logical.
Share my screen. You guys see me now?
I see it. Okay, I see it.
Yes.
I think it's this
Oh,
one.
that sensor. I have yeah. There's a sensor. Yeah, we have a development board for that one somewhere, I think. AHT10. Let me just double check that. I think there's a development board for it. Sensor. Yeah, there's tons of them on Amazon. You can get them, and yeah, Adafruit has them. 278 in stock. So here, let me show you this. I'll just share my screen real quick. So yeah, they're real cheap.
Yeah.
278, no problem. So we can get you a couple of those. Yeah, perfect. There's definitely an Arduino library for that then.
Anything else with the software test?
No.
Okay. I will send my files that I just showed
Okay.
to you guys.
Yeah.
So
that's awesome. Something to do this week.
So last time I asked the question about switching the converter to
Yeah, that looks really good.
64. So I did two of these. It says 5 volts and 3% volt output, but it's gonna be 5 volt and 12 volt. I'm just gonna
How
switch
come you have two capacitors stacked up here?
over here.
Yeah.
That's let me see
I
if
don't
I
think
have
you need that. That's not gonna help you much. I think you need to put them in parallel if you want to double up the capacitance. They do that?
Actually, I'm not sure, but I'm showing you the circuits over here. Let me find that.
Where's the footprint?
That's not the one.
No,
no, this is not the one.
oh, you just
over here. So it has 2 times.
Just one here. Oh, put them in parallel.
In parallel?
Yeah.
Okay.
When parallel capacitors, you get double the capacitance, but if you put them in series, you actually get less capacitance.
Got it. Okay.
Yeah.
I'm gonna switch that up. And
you know what these capacitors are for?
For how to say? It's to regulate the noise.
They're just filter capacitors.
Filter? Yes.
Yeah, C3 here. C3L, R1 and R2 are the big ones that regulate the voltage output.
Yeah, so because we just changed our output today actually, but it's not gonna be a problem for me because it got I got data for that.
Yeah, this is good.
So I actually also did the PCBs
Okay.
But it passed the design rules checker.
Yeah.
But it's just that because I need to connect this board to
Okay.
my
So-
transformer and not.
Yeah. First thing I see is the diodes, right? D1 and D2, you have this trace.
D and D2.
D1 and D2, yeah, right? You have a trace going really close to that.
Mm-hmm.
You want to move that trace away from D1, D2, the one that wraps around it.
You mean these come
Yeah,
across
it's too
them?
close. See, you're kind of in this little area.
Okay.
Yeah. You
so
need
you
a way
mean-
to connect to D1, D2.
Yes. That was because my transformer. There's just like two wires.
Yeah.
I have
I
to find a
think
way to connect them.
C1 and C2 and C3 are pretty big capacitors.
Because over
Probably
here
might
I used like the I don't know the 0603 footprint.
Yeah, those are big filter capacitors, I think.
Oh, let me see if I have the. So these are my
Yeah,
design.
C1, C2, those are very large capacitors. You're going to have to use electrolytic through-hole capacitors there.
So I have to change the footprint. Do you mean?
Yeah, yeah, those are. You're not going to be able to find a 10 microfarad capacitor in a 0603 package.
Okay. So what I do now is I have to like find those capacitors on DigiKey and see their footprints and switch
Yeah,
my PCB
Yeah,
design.
you're going to need like a through-hole capacitor. I have some that size too. If you put most any through-hole pattern, we can match it and figure it out. It's
Okay.
not a huge deal. But
Okay.
yeah, you can't find a 10 microfarad capacitor in 0603 size.
Okay, I'll fix that. I'll
then-
fix every
yeah.
component over here. And yes, so just like I said, I have to find a way to connect this board to my transformer and also to Arduino.
Yeah. Header pins, 2.54 millimeter header pins.
Header pins. So I
Yeah.
find that also on DigiKey and find the footprint for it. Then
Yep.
implement
Yep.
that on
And
the.
you're definitely going to want to make the traces a little bit bigger coming from the power
Traces?
section. Yeah. You're going to have
Oh.
quite a bit of current on those right off the bat. Like, I'd say double the size of them.
So
double
you mean for these wires I have to make
Yes.
make it double
Yes.
size? Okay.
Yeah, they're way too small.
Okay. So other than that, anything else you think I should change?
Looks pretty good from, where I can see it here. I don't see any really huge.
Because I've never really like built a PCB before.
Yeah, right here, when your C13 is going through C6,
C13.
on the upper right hand right here, yeah. So you're going through the trace there. I probably would recommend putting that on the other side.
You mean this one in the middle?
Yeah, that one right there.
Okay. And the reason is
Just you're cutting it too close.
So is this trace like going between two
Yeah,
of
it's-
the
If you
capacitor?
can avoid that, I would avoid doing that if you can, because
Uh-huh.
it's you could easily kind of damage the solder mask, and then next thing you know, you have a short.
Okay. So okay. Okay. Got it. So just don't try to not run everything through
Yeah.
the components.
Yep.
Okay.
Can you send this file to the PCB done? When you finish these updates, can you just send this to me? I'll take another look at it.
Yes, I will do that.
That's awesome. And how big is the inductor you need for this thing? Because I don't know if is that the correct footprint for it?
The inductor?
Yeah, L2.
So the values should be
10 microhenry. That's small. Okay.
that's small. Okay.
Yeah, maybe. Do you find the part with a 0603 footprint for a 10 microhenry?
No, I didn't go look for the parts.
Okay, yeah. Before you do the part layout, you gotta find the correct footprints for everything. It's really
Okay.
important. Because usually inductors have a slightly different footprint than your capacitors and resistors.
Okay.
Mhm. This looks good though. It's a really good start, guys.
Are we going to be like buying these stuff, or I'm just looking on
That'll be fine. Yep.
Okay, got it. So yeah, so basically change the make sure the component footprint matches, double the tray size of the trays, and put header pins for both transformers and Arduino.
Yep. And then C1, C2, and C3, those filtration capacitors should be changed to through hole.
Through hole.
Yeah, because they're big capacitors. You know, they're filtering. And then just make sure L1 and L2 you've got the right footprint for them.
Okay. After I make those changes, I'll send the files back to you.
Yeah, awesome.
Yeah, I think that's everything on my end.
Okay.
And I didn't run the LT Spice here. You know, I don't have the models, so
yeah,
I guess we have to.
You gotta double check the math. That those parts should have some formulas, you know, for them, and it should be just kind of showing you exactly what values to use.
Okay. Yeah, I'll do that.
Okay. Nice. Okay. Any other
Anybody else
pieces?
with Dion, you have PCB, right?
Huh? Where? I haven't drawn yet. I just got the schematic.
Okay.
So you want to show us?
Try to get that done this coming week, okay? Can you get something done by Wednesday?
Pardon?
Could you get the changes made by Wednesday?
On me?
Yeah, the PCB started
By Wednesday.
Wednesday. Because yeah, 5 days.
Yeah, of course.
Cool.
Probably.
All right. You guys are off on a good start.
Okay. So is that everything? Anybody else have any questions for me?
Yeah, so I got the questions for
Sure.
the PCB2 I was building, because should we put our buttons on PCB board or?
Yes.
Yes?
Yeah.
Okay, sure.
You can just get surface mount like little tiny buttons. I'm gonna pull something up here. Yeah, okay, so let me share my screen real quick. So, stuff like these are totally fine. You know, 13 cents on DigiKey. So, real easy. This is 40 cents, 17 cents on DigiKey. No big deal. These will work just fine.
Sure.
You might want to put a capacitor to debounce them a little bit, but that's it.
Okay.
I have a question about the Arduino Uno board.
Okay.
So basically, that board just need to 7 volts, and we can drive
the Arduino can take usually 5, 7, or 9 volts. 5 is probably optimal.
At least we have to get 7 volts.
7 volts? Okay.
Mm-hmm.
That will work.
Yeah, because we we have three sensor. We'll just got the power from our dashboard. So we think we increase our power supply voltage to 12 volt. Is that make sense? Or
I don't see anything that the relays, the Arduino boards are basically 5 volts, and the sensors you have are all 3.3. So 5 volts, I think, is where you want to be. And I didn't see any 12-volt devices in here.
I mean, we have to get a 7-volt from the power supply to drive the Arduino.
Arduino will run on 5 volts, no problem.
Why? What do you have? What do you need? 7-volt.
I mean, just we have got the 7-volt, right? We just discussed this about this part.
Arduino's
Didn't Bill said that you can run on 5?
Yeah, 5 volts is fine. You're just gonna burn off that 7 volts.
Oh,
No, I'm not saying anything. I just want to make sure, like, why you have to use 7 volts.
because the data sheet we have to get a 7-volt.
No, the data sheet's probably gonna say you can use from like 5 to 7 volts. 5 volts, I'm gonna say, is probably what you want to use.
Okay.
Also, where does the, like, you also asked me for like 12 volts. What? Why? Like?
Because we think we have 3 sensor have to get the power from
But
Arduino.
sensor are not getting the voltage from me. They're
From-
getting
from me.
from you. Yeah.
The
So why am I?
sensors do not need that much power at all. They probably need 20 milliamps at most. The sensors are very, very, very current friendly. So you could probably power the sensors right from the Arduino.
Right now, I'm pretty sure that the water pumps like take 5 volts from me. And so, what about the Arduino?
So we're going to use a relay switch for the water pump that would turn on the water pump.
So, which means that I don't need to provide power to the water pump either.
No, you're just going to provide power to a relay. That's all you got to do.
Okay.
Because relays are water pumps for big greenhouse systems would be probably 100 volts, AC, to push some serious water. And a fan would be, it could be up to 220 volts or 400 volts, depending on how big the greenhouse is.
So are we like simulating that kind of situation? Because right now we only have like tiny little parts.
Yep, we're just simulating. We're proving the concept.
Okay.
Yeah, we're just going to use relays. Easy.
So can somebody clarify like what is the output for my power supply right now?
I'd probably say 5 volts.
So 2 5 volts output or
A 5 volt and a 3.3, I would say, would probably is what you want.
is that the 3.3 for the relay or?
3.3 can be for the sensors, the relay, or any of that stuff. Yeah, the relay probably 3.3 volts.
Okay.
Or,
So it's back to 5 volt and 3.3, right?
yeah, let me check on the relay though. The coil might be higher. The coils can be 12 volts. So,
We're using MOSFET, not relay, right?
you're using a MOSFET to turn on the relay. Some of these here, like this one here I'm looking at here, 12 volts. So I would say 5 volts and 12 volts then.
5 and 12? Okay,
Yeah.
I'll do that.
Okay. That'll get you
Okay. Can I share my screen and
Sure.
just show the data sheet here?
Yeah.
Okay, can you see my screen now?
Yep.
Okay, so I just know operating voltage is 5 volts, but
Yeah.
input voltage recommended just 7 to 12. So which one I should?
5 volts is fine. Yeah.
Oh, 5 is fine. Okay.
Yep.
Sure. Okay, no problem. Okay, so our power supply is back to 5 volt and 3.3.
Yeah, let me show you my screen real quick.
Okay.
So this is kind of what I have in mind for the relay. It's 12 volts. You can switch that. You can switch on 120 volts AC with that. And that would turn any fan or any pump on, basically.
Nice.
Do we have relay in our process?
I got a bunch of these, yeah. I'll give it to you Wednesday.
If I were using relay for this, because I'm thinking about just using MOSFET to open the water pump and other things else.
Yeah, MOSFETs will turn on the relays. I think that's the best way to do it. Relay is going to be hard to turn on with an Arduino. I don't think you're going to have the current. So you'll turn on, the Arduino will turn on a 12-volt power supply with a MOSFET that will turn on the relay. That's probably the best way to do it. Does that make sense?
Mm-hmm. Okay.
Is that everything?
Question?
Okay. Well, if you guys have more questions around Saturday and Sunday, I'm not going anywhere, so feel free to ping me at all. No big deal.
Good.
Okay.
All right. Thank you.
Okay.
I'm stuck here for a while, so. All right, guys, good job.
Thank you.
Have a
Thank
good
you.
weekend.
Thank you.
You too.
Yeah, great weekend.
Bye-bye.
Bye bye.
So